as you, of course, go deeper into understanding their stuff, then you'll get to realize that, of course, they do have archives where they keep where we keep old material, and from that old material you can pick it up and, of course, do the old challenges and, of course, come to understand more. How would you set up yourself here, for example, in this? How would you set up yourself here? Here, all you actually need is an internet connection. You can have, these guys have been able to use workspaces and desktops, which are basic views here that you can use for you to actually be able to connect and have web-based access to their labs. So why do I really emphasize the importance of, for example, this specific platform that I'm encouraging you to join? I am not a marketer of this platform. I'm not a student at Arizona State University, but I'm also telling you from my experience over time that one of the materials that I found super helpful, and also as you come to realize that there are platforms where you can grow as a security professional and also actually interact with fellow security professionals or students that are basically at the same level with you, I would say academically, because most times you'd find that, for example, you can be maybe say 20 years or 25 years old, and you find that the student you're going to be discussing this with, for example, in the Arizona State University Discord channel, is, for example, 19 or 18. But they, of course, have vast knowledge around these topics. And once you're able to, of course, pick up, for example, from these platforms, most of the platforms will be walked through, because from what I will tell you as a person, I have seen how much rich and knowledge this platform is compared to most of the platforms in terms of an embedded security and also a low-level security understanding. And also, of course, the skilling that comes with it. Because not only does it give you junior challenges to build, it picks up on your different skill sets per challenge that comes through. And from there, when you're able to, of course, pick up more challenges, then you can, of course, get a belt. I don't have a belt yet because they're really quite hard to get. But of course, I believe I will definitely have to get one of these nice belts that you can earn. And of course, even if you're not a student, this is shared to you across anywhere in the globe. And trust me, it's really a big thing to have because of the complexity of the classes. So why I still emphasize on this, you can get to read. Joel, you can share this material for the guys so that they can pick up. We shall be, of course, using this. We shall be using CrackMe, and then, of course, we shall also be using RootMe. We have CrackMe, then we also have RootMe, which is another platform. Joel, please highlight and drop for the guys. We also have RootMe. RootMe is also a platform that probably you would get challenges that you can play around with. It's also a good platform where you can interact. Of course, you have to have an account. It's I think based in France, but of course, I think it also has good material if you're looking at the reverse engineering side. So, well, that is like the first half of this session. We're going to take a 5-minute break. And then, of course, from there, now we are going to dive straight into the x86 architecture. And then we, of course, do a sample for us to be able to maybe brainstorm the few things that we've gone through and share. So basically, that's the first lab. Let's take a break for 5 minutes and get back at 7:35. Joel, you can take over. During this break, you can ask anything. I think that would be the best thing as we maybe prep and resume at 7:35.
Okay, thank you very much. Hopefully I'm audible enough. Please, if you can hear me, type yes in the chat section. Okay, thank you very much. Thank you, graypwn. I've shared the links to the platforms, including Pond College, including rootme.org. You can share as you go along with it. Probably That's the places all of us went to learn. So I expect you all to try them first, so that you can, because the moment you jump the basics, that's the end of you. So you can check them out and see. Maybe if you have a question, you can shoot, give us a question, and then we can see how we can go about that before the break resumes. Thank you.
Yeah, I would like you to, pardon for me, this from you. So, I like you more about the business.
Maybe you can pardon the question you're saying. What can we highlight?
More about the business for cyber security.
I don't think I can get you well. Maybe try to rephrase your question so that we can know what exactly you're asking. Thank you.
Yeah, I'm saying that highlight more about the business of cyber security. I don't know if you can hear me, but uh, what I'm saying is
I,
that we highlight
you can type
more about the business of cyber security.
you can type the question in the chat, maybe. Okay, yes, Cliff, you're asking about to highlight for you about basics of cybersecurity and penetration testing. Peter is going to go about that, but basically, just like you said, you want the basics. I think the best way to go about basics of penetration testing and ethical hacking, one is utilizing these platforms. All of them are free. Others are paid, but trust me, I always encourage people before they pay, they can first do the free things. So you can try to go to TryHackMe. I'm very sure by now you should have tried TryHackMe. And that TryHackMe, I'm very sure all of you have ever tried it. So that's all of us. If you want to do the basics, that's where you all go. And basically it looks like this. And trust me, it has a path. It has a path, and it's those the path is always free and free for you to learn. There are also beginner friendly challenges. If you go under learn or under practice, you find the basics of everything. Or if you want to learn, you can learn through these modules and so on and so forth. All these red teaming and junior penetration tester. So they are worth it. They are really beginner friendly, and I encourage you to try them. And basically, also, Cyber Talents also has a full-fledged materials for learning. If you log into Cyber Talents, also has an introductory course for cybersecurity. It's for free. You can always go and try it. So I'm very sure you all ever tried it. So you can try it Maybe if I can log in and I show you, and it's always free. Oh, okay. Let me try to share again. Sorry. Okay, hopefully you can see my screen, right? Okay, thank you. So this is cyber talents. For those that want an introductory course, penetration testing, ethical hacking. If you go to Underlearn, there is a beginner path. For those that want basics, the beginner path. A beginner path includes one, but of course you have to first enroll. But it includes 2 units, and those two units have one, a Linux practitioner and introduction to cybersecurity. So for the basics, I encourage you to try these. They have a lot of labs. Up to you can try them out, and trust me, by the time you finish 44 labs, you'll be good to go. And I think they are resourctive, they are exhaustive. Because if you go to under, for example, if I go to under units and I check like introduction to cybersecurity, you'll see the lessons that are in there. A lot of lessons, everything you want. So a real quick one maybe to show you, as you can see, everything, introduction to web security, HTML, hashing, cookies, JavaScript, encoding, directory traversal, suite, everything here is free. SQL injection, code injection, and so on and so forth. Trust me, by the time you finish all these, you're really good to go. And trust me, you can head over to TryAcme and try this path. Okay, I think that is all. Thank you. Maybe I can hand over back to Peter. Someone is asking.
Thank you, Joe. I think we're running out of time. So going back to where we were before. Guys, confirm when you can see my screen. So basically, I was starting to break down the architectures basically. For example, this is what we understand by the x86 architecture. It has, of course, different types of registers. Basically, the general purpose registers, as we know, the EAX, EBX, ECX, EDX, EBX, ESB, ESI, EDI. Basically, this is like the accumulator. You find that these different registers have different functionality that they play, and you find that they're 32-bit registers, hence the 32-bit architecture, basically. So what happens is because these sessions are short and we expect, of course, the teams to be able to pick up some things, of course, we shall be dropping some notes for guys maybe to take up, to pick up, to sit back and review. And of course, feel free to reach out, as we said. So basically, when we're looking at from a registry point, we find that these registers are basically different. They're like pockets of memory, basically. And they're used for different operations. For example, if you find a 64-bit system, you will definitely have them have different types of register. For example, let's just try and maybe just break down, just confirm when you can see. Okay, for example, let's say I have a file here. I have a file called test. You can see that, for example, it's a 64-bit file. And there are tools like, for example, Radea that can help us analyze some of these files. For example, when you run Radea, and then, of course, that AA gives it analysis. And then we can, for example, look at the different functions we have there, and then maybe switch to the main function, and then maybe just break down to understand and see what's within it. So basically, Radea is it's a reverse engineering tool.
Excuse me, Peter, I can try to zoom the terminal. Thank you.
Okay. Okay. So as I was saying, I hope you guys can see my screen. So we have, like, for example, a tool called Rabin, which is part of the stack that comes with Radea. which is a tool, basically, you find that, for example, it can give you information about a specific file. For example, here we see it's an ELF, which is a 64-bit. It was compiled on an Ubuntu machine, basically using GCC. And yeah, basically you can see it has it's for Linux. It has position independent code implemented, and all these are different modules. Of course, we are going to learn how they basically come into play and how they affect the binary. The language that was used for building is C. And does it have some code? We can see yes. And of course, that means it will be easier to break it down or reverse engineer the file. So when we have some tools, for example, personally, I use Radea if I am on Linux, and when I'm off Linux, for example, using Windows, I probably use a tool like Ghidra. Ghidra is another good tool for decompilation of the different binaries or ELFs, and it can also give you great visibility on how the registers communicate. So what I meant was, when I was explaining about the architecture, for example, in this case, we have a 32-bit architecture. We have basically EAX, but when we go to look at, for example, with Radea, and we look at, maybe say, the main function, and then we break down the registers, we see that we have registers that have R, and these are 64-bit registers, basically, of which we have, of course, this guy, which is our accumulator or our return a register, that is RAX. But with the 64-bit, we find that it's what? It's EAX registers. So basically, what these things do is they have different operations that they're used in. This one is majorly used when you're returning from a specific function. Here, EIP is basically used for pointing to the register that is going to run the next instruction. What does this mean? For example, if we have different tools that we can use. There's also another favorite tool that you're using when you're doing static analysis. Majorly, there are tools that you normally first use when you're doing reverse engineering. You can analyze a tool basically from the static side. You can analyze with just simple tools, even just like strings. Like strings is just a simple tool that you can use. It is a good utility of which it seeks for any form of like, for example, syntax that is readable, and then it will print it out. So for example, here you can see the different shared object libraries which are in use. You can see some functions, some functions which are used, like the string copy, the puts copy, the puts, printf, string length, signal test memory set, sig action, basically all this. Then also, of course, you have our GC libraries that are in use. You can also see, for example, there is a word called challenge. There is also maybe HTTP, which is probably, I think, a flag format and some string formatting here. Then, of course, you can see that maybe the name of the file which was compiled was called CRT stuff. So basically, this file is not stripped. When we talk about stripping, basically, we find that with stripping, you try to you optimize a file in a way that you remove things that are not garbage. For example, if I have, when we understand the difference in data and code, we look at, for example, if I have code and data, you find that if I can remove and still achieve the same functionality, I'm optimizing things like runtime, basically time space complexities, and you find that this is what normally we achieve, like, for example, with stripping. So in this case, we're able to use strings to understand, okay, that there's some information that's given by the binary. There is some form of flag format that is there. We can see the compilation, the shared objects, and things like that. So basically, you can use this for static analysis. You can also even use Radea just as is for, as you can see, for static analysis. Basically, you understand which functions are there. You can see some dummy functions, and you can also refer to them to be able to understand exactly what the binary is doing. In this case, you see that, for example, these are imported symbols. So these are already like known functions within, for example, the implementation of different code syntax. For example, you can find a printf. It's basically used to print something. So this function is, of course, known, but it's imported into your code so that it can be executed to to run a specific purpose within your code. So normally, whenever you hear, for example, when for example someone is saying, "I am going to write an exploit for vulnerable code," sometimes people still use functions which are vulnerable. For example, you find someone running fgets gets or string CMP or definitely like functions which are vulnerable. And normally what an attacker or developer targets is, for example, how can I look at manipulating the input to a specific vulnerable function that is being imported. Once you're able to achieve that, most times you can either jump out of the code to maybe achieve remote code execution, or jump into another section within the execution of the program for you to be able to achieve whatever objective you want. Those are now, of course, the techniques that we come up with, for example, for bypassing or cracking software, or, for example, achieving maybe a specific function that would probably do a demo with time. So when I'm going back to understanding another tool we can use, we can also use GDB, which is basically, we also have GDB. I don't have GDB installed. I could just install it quick, because this is a new instance. So GDB is a very powerful tool. It's basically GNU debugger. It's majorly what we use. I'm having some interesting things going on. Some things are breaking. Okay, as that's compiling. So you find that, for example, you have a function that is running, and for example, you have a binary that you're executing, and you reached a point in like where you're running static analysis, and you actually when you're running rather dynamic analysis, and you want to understand how the different how for example your code is being executed in memory. You can use just a minute. You can use things like GDB to be able to set breakpoints during execution. And when you're able to do that, then of course from there you'll be able to look at, for example, how this specific code is being executed. So let's get our GDB, and then of course we can proceed and go and maybe just show you a demo around it also. Yes, Warren. You said definitely. Yes, reverse engineering basically for Linux and Windows is definitely different, and also of course at ARM level. ARM, of course, if you're looking at, for example, Android, they are all different, and of course they have different registers. But the first important thing that I always tell people is, when you're getting into Rev, one of the things you need to understand is how to think outside the box, because no one will tell you that, for example, no one will teach you how to understand how, for example, a specific set of instructions constitutes to maybe a specific for loop or an if clause within a specific within code at a higher level. So understanding the different registers, for example, for ARM, ARM's registry syntax is definitely different from those of x86 and of course or the 64-bit. So it's something that you got right. But of course, as I said, since we are starting with Kali, we shall start from the Linux bit. Then of course we shall go and also go through Windows with time as we get more time. And then of course I can even introduce some of my ARM friends to come and actually take you through. But mostly all this will be done majorly when we are actually starting to study binary exploitation. So basically we've got our GDB installed as we had promised. So GDB is basically GDB is a debugger, as I said, and you find that it's basically used for most of the compilations. It has also its own strength, and also of course it's also something that you probably need to learn. And of course, even its advanced usage and are taught via the Pwn college class, so you can also pick it up from there. So with GDB, if we are also to, for example, look at how GDB GDP works. You can also see GDP when we're using Radea. Just a minute. One split my screen. Vertical. When we're using R2 and we're reviewing the functions, you can see, for example, here, this is basically almost the same if you understand exactly what's happening. You find that also GDP, when of course you're doing static analysis, it still gives you almost the same view. For example, in terms of functions, you can see functions here that are basically being used within the different within the code. So the only difficulty normally when you come with GDP is compared to Radea is whenever you're looking at, for example, how GDP works majorly with stripped code, it's not the same with Radea. Radea can still go down and break down even the stripped code or the obfuscated code and be able to at least give you visibility on what's happening at a low level. It can give you some visibility. Sometimes it becomes very tricky with GDP, and you'll of course need to go down to the level where you where you will of course have to go into dynamic analysis to be able to understand what most of the code is doing. So in this case, basically what I'm showing you is there are different tools that can help you achieve the same purpose, and it's up to you basically as a reverse engineer to know which best tool you can choose to be able to help you do your operations. Sometimes you can reach a point where, for example, you're dealing with malware, for example, actually dealing with malware, and sometimes it's not advised to even actually use specific types of OSs. So we have also machines like, for example, Remnax. Remnax is basically a hardened box built specifically for analyzing malware, and it has almost all your reverse engineering and analysis tools. It also you can also look at it. It's basically, I would say, it's a very advanced project around majorly malware analysis, because you can do all different OS types basically of different types of malware and be able to analyze on the same box. So it's also something that maybe you can share just for the amusement of people who are really actually interested to go down that path to understand this. So highlighting basically what we defined, the major reason why we go down to start the fundamentals by explaining, for example, what happens at a low level and the importance of maybe understanding, for example, registers in this case, we find that if you're not able to understand how your registers basically how your registers are used within a CPU by a CPU, you find that, for example, you will not be able to actually break down and understand how your code is running at a low level. Because most times the reverse engineering, even if, for example, yes, at this point we're looking at low level, but reverse engineering cuts across. You could be having a Python code and you want to work backwards for it. You will definitely have to use this. It may not be the same tools, but of course it has to be the same knowledge basically around how best you can get out of that problem. So, for example, there are small utilities that very few people sometimes review them or think about using them, but they're very important. For example, we have a tool like, for example, ltrace. Ltrace is a very simple tool, but very powerful. You get, for its work is it helps you map out the different library calls by a specific program. So as you execute, for example, let's just give a test. If we say ltrace and maybe test, you find that, for example, we are seeing sigil, basically illegal instructions that are happening at the CPU level, but it's still able to actually tell you that there is this issue that is creating, basically there is a bad instruction within your code that is making it fail to run. Then also we have another utility called strace. It's basically the system library version of ltrace. I don't have it also installed. You guys will forgive me. Basically, this is a new box basically set up for this training. So so we also have maybe say S-stress. S-stress, as I said, basically for it, it's very different from L-stress. How is that? For it helps you look at basically system calls, and it will help you look at system calls. The other one will help you look at the libraries that are being called, as you can see here. So you find that when you go low level and maybe you want to, if you're getting interested in binary exploitation, S-stress may be something that you definitely have to pay attention to, majorly if you're moving from if you basically want to make system calls to maybe carry out different operations at a CPU level. Basically, this is what you'll definitely be working with. So if we're going back to the tools that we talked about for maybe your thrill and understanding, we talked about simple things like files, like strings, like Rabin tool. There are so many different tools basically that you can use for breaking down your binary, depending on whatever purpose it is, so that you can be able to understand how best we can go about doing analysis for a specific binary. Another very interesting tool is, for example, Ghidra. As I said, Ghidra is a very interesting tool. I don't know whether, let me set it up for you guys so you can see how it works too. Then we also have another tool called Kata. Kata is also a very interesting tool, which is Ghidra is basically something. It's the NSA's. It was basically something that was being used by the NSA, but was of course one of those tools that were leaked at the time when of course some shit happened, and yeah, you of course get to use it. As you can see here, the developer is NSA and basically helps you do so many crazy things. It's maintained by an NSA, and of course all it just requires is Java, and yeah, it should be able to execute within your specific system. Then another tool which is equivalent to we have is Kata. Kata is Radea's, I think. Kata is oh my god, this will be interesting. So yes, so we have like Kata. Kata is basically a very simple, interesting tool also that you can use. It gives you some breakdown of different binaries, system calls, library calls, and you can see basically it's also a very powerful tool that you can use. So basically, what we shall be expecting is that we get familiar with the tools that we've highlighted here, and then of course, when we start from our next session, we are going to be going through actual hands-on x86 architecture, and maybe also doing a few crack maze here and there to better, of course, give people the understanding of what they're going to be going through. So what we'd expect of you, of course, when you're coming to the next session will be at least to, one, understand how the x86 architecture basically is implemented. And then, of course, we shall pick it up from there. It was majorly this review that I wanted to go through for introduction. And then from there, from the next session that we can pick up, Joel, we shall be actually going hands-on. It won't be showing tools. Thank you guys for your time. My time is up. You can feel free to ask any questions.
Yes, good evening. I wrote down a question in the chats, but it wasn't responded to.
No, actually, Warren, I think I responded to you. I told you that basically with Linux, of course, and Windows, we have different labeling for the different registers. And of course, the x86 architecture for the implementation at a Windows level and at a Linux level is different. But the reason why we started with Linux basically is because from a cybersecurity point of view, most of the professionals, when we are starting out, I would probably make the assumption that if everyone is trying to either be a researcher or really deep into, for example, penetration testing, in this case, offensive, you find that most times you're dealing with Kali, and you want to be able to get very familiar with, for example, how the different elves you have on your machine are, or for example, when you're looking at previous privilege escalation, how best you would walk around with these. Of course, are the first things that you get to interact with more often and have very available with you, so that you can be able to what to actually test. Because if, for example, we say, okay, let's have a discussion around ARM, I don't think everyone has a boot up where they can just say, I have ARM here and we're going to use it. So, of course, well, as you had highlighted, there are differences in this. And of course, we shall be taking on and explaining most of these differences as we go along. I don't know whether that answers your question. Thank you. Thank you, Warren. Anyone else? Maybe Joe, you can pick it up from there. Joel, are you there?
I think you can finish it. You can finish it. You can give them the closing remarks and we call it a night. Thank you, man.
So, guys, I really want to say we appreciate everyone that is on this call, and because for me, I don't know, I'm someone who believes in knowledge, sharing of knowledge, and of course, exchanging ideas. And there is no way you can get better without having a community that is either available to support and maybe share ideas with, because every time you find a challenge, sometimes maybe above you, sometimes maybe below you. And of course, having someone who you can reach out to is very important. So we appreciate all of you who have taken the time to come here. And we hope that on the next session, we can be together and help each other and support each other. So thank you, everyone. Have a lovely weekend.
Thank you very much.